Hello everybody. Today's video is on understanding the web as an ethical hacker. In this video, we are going to be covering the following topics. So first is the World Wide Web. Then we are going to talk about HTML and URLs. And we are going to get a brief overview of what happens when we visit a website using a web browser. Then we are going to look at the protocol used by the web, which is HTTP. We are going to look at the different types of requests, their responses, and we are going to understand what are headers. And since we are taking a look at headers, then we are going to talk about cookies and virtual hosting. Lastly, we are going to be talking about the security problems with HTTP and their mitigation mechanisms, how we can mitigate them using HTTPS or HSTS. So now let us look at the World Wide Web. The World Wide Web, often abbreviated to WWW and commonly known as the web, is an information system where documents and other resources are identified by uniform resource locators or URLs, which may be interlinked by hypertext and are accessible over the internet. So what this means that the World Wide Web is a system of computers where documents and other web resources, which can include images, videos, graphics, animations, and other things, are identified by uniform resource locators or URLs. And URLs are the text or the things which are used to pinpoint the location of a resource on the internet. These may be interlinked by hypertext. Hypertext refers to the text that contains hyperlinks. Hyperlinks are those pieces of text which contain a link to a different URL. For example, all the text that is blue in color in this web page leads to other web pages, and so all of the blue text is hyperlink, and so this is hypertext. These are accessible over the internet. These resources are transferred via the Hypertext Transfer Protocol or HTTP, and these may be accessed by a software application called a web browser. Now, most of us are familiar with a web browser. Examples are Google Chrome, Mozilla Firefox, etc. And these are published by an application called a web server. Sir Timothy Berners-Lee invented the World Wide Web. Now, web resources which can be accessed over the World Wide Web can be of any type. These can be executable files, these can be simple text files, PDFs, images, audio, video, anything, even documents, and these are may or may not be formatted in a special markup language called Hypertext Markup Language or HTML. This markup language allows us to embed hyperlinks and other resources inside hypertext. Let us try to understand all of this with a more technical overview of what happens. So first we have a client and we have a server, and they are able to communicate with each other over a medium. It can be that they are communicating over the internet, or they are connected to each other using Ethernet cable, or they are on the same network. It does not matter. Only thing that matters is that they are able to communicate with each other, and the server is a web server. The client has a URL which is http example.com/readme.txt. Now it will use something called DNS, which is another protocol, and it will send this URL to a DNS server. Now the DNS server may be on the same network as the client, or it might be somewhere on the internet. When this URL is received by the DNS server, it will convert it into the IP address of the web server and send it back to the client, so that now the client has the IP address of the server and it can connect to it. Let us assume that the server is running with default configuration and that it is using HTTP. Now the default port for HTTP is port 80. So whenever we connect over the World Wide Web to any web server, it always connects over port 80 if it's using the HTTP protocol. So what happens is that we connect to port 80, and let us assume that we want to access a resource called readme.txt. So we send an HTTP request for readme.txt after connecting to port 80 on the web server. Now the web server looks in the directory in which it is supposed to serve and sees if a readme.txt file exists. If it does not exist, we straight away get a message or a response which says that a file with this name does not exist, and if the file does exist, it checks whether we or the user which is trying to access the resource has authenticated with a username and a password or some other means, and if the user has the permission to access that specific resource, and if we do not, it straight away tells us that you do not have permission to access this resource. But if we have permission to access that resource, then the server will send the resource to us, and then our browser will render that resource according to its format. So if we requested an image, it will send back the raw binary data of that image, and our browser will parse it. If it is a video, then it will parse that as a video. If it is in some format which the browser does not understand, it then asks whether the user wants to download this file, since the browser is not capable of parsing such a file. So now let us talk about HTTP, or the Hypertext Transfer Protocol. Now, as the name suggests, this is the protocol that is used to transfer hypertext or any hypermedia across the World Wide Web. It was also made by Tim Berners-Lee with the creation of the World Wide Web. It uses certain methods to communicate. The most prominent ones are GET and POST, GET being the one used to fetch data from the server, and POST being the one used to send data to the server. It communicates in plain text, which is its biggest drawback. More on that later. Then we have the three major versions, which are HTTP 1.1, 2 and 3. The earlier versions, that is 1.1 and 2, communicate over TCP, while the newest version communicates over UDP. The default port for HTTP is, as I already told you, port 80. Now let us talk about the different methods used by the HTTP protocol in which the client communicates to the server. So when the client communicates with the server, it is the HTTP methods used to either retrieve data or to send data. So if we want to retrieve some data from the server, then we use the GET method. As the name suggests, we are retrieving or getting the resource from the server. Its format, or the format for any HTTP method, is first the method name, space resource name, space HTTP version, and then in the next line, from the next line, we have all the necessary headers. So the same goes for the GET method. We have the word GET space the resource name. Now if there are some variables that we need to send along with the name of the resource, then those are included in the resource name. Next we have the HTTP version, which is written as HTTP/ then version. After this, it is terminated by a new line character, and from the next line we have all the necessary headers. So similarly, like the GET method, we have the POST method, which is a lot similar in format to the GET method. The POST method is used to send data to the server. So whenever we fill a form or post a message, the data is sent using the POST method. So the format for HTTP methods is nearly the same. It begins with the name of the method, so which is POST in this case, then the resource name, and then we have the HTTP version and the headers, and lastly the data we have to send to the server is written at the bottom, which is separated by a blank line between the headers and the variable. So in case of GET request, any data that we have to send to the server is sent along with the name of the resource. However, in the post request, since we only have to send the data to the server, it is sent after all the headers are sent. Now let us talk about the response, what the server sends back to the client. So the response for most of the methods is similar. It begins with the status code, which is a 3-digit number which indicates what happened with the request, if it was a success or if there was some error. Next, we have some necessary headers which might be required. Sometimes this tells us the type of server running, which the web server is running, and some other things. Then we have a new line or a blank line, and after that we have the body, which as you can see is optional. So why is it optional? Because if we send a post request, then the server does not need to send us anything except then telling us if the request was successful or not, which is done by the status code. But if we send a get request for a particular resource, that resource is sent in the body of the response. So if I sent a request for readme.txt file, I would, in my response, I would get the contents of the readme.txt file inside the body of the response. Next, we have status codes, which are used to tell if the request was successful or if there was an error. So the codes between 100 to 199 represent information, 200 to 299 success, 300 to 399 redirect, 400 to 499 is client or user error. So there was an error on our side. 500 to 599 represent a server error. Some of the most common ones that we see a lot are the 200 success, that it was successful, 404 not found, which means we were trying to access a resource on the server that does not exist. Sometimes we also see 500 internal server error and 403 unauthorized, that we are not authorized to view that. And we many a times also see 301 and 302 redirects. So we have talked about the different methods like get and post. There exist many more, but these are the two most common ones, and we have also talked about their responses. So now let us see this in action. I am using the Mozilla Firefox web browser. This will also work in Chrome and all other browsers. So I have used F11. I've pressed F11 to be in full screen mode, and I'm going to open developer tools in the browser by pressing F12. You can do the same by pressing F12 or Control Shift I, which will do the same. Now there are many tabs open. We have the inspector, which allows us to see all the elements on the screen as well as their corresponding HTML code. For example, I can click on this button and select any element, and it will point me to the HTML code responsible for that. For example, if I click on this logo, it will highlight the code which is responsible for that logo, as you can see this. Then we have many other tools, the JavaScript console, debugger to debug JavaScript files, the network style editor, that is CSS, performance, memory, storage, accessibility, and many other things. For now, we'll focus on the network tab. Now this will keep a record of all the requests made to the server. Now we are going to press F5, that is refresh this web page. So as soon as we press F5 and we refresh the web page, we see a lot of requests going to the server. These are either get, post, and we see their response to what domain they were sent and the file requested. Now one thing that you should know is that most of the time we first send the request to the slash. Now slash is interpreted by different types of servers differently. Most of the time it defaults to index. So if I have a file called index.html or index.php in my web server's root directory and I try to access the slash, it will convert this slash into index unless I have specifically configured it to not to do that. So we can see the different method used, and if I just click on any one of this, it will show us the raw request it sent and what request it received. So we see here that it used HTTPS, then the host, file name and the IP address, and you see that it connected to port 443. Why 443? Because it used HTTPS. We are going to discuss about HTTPS at the end. And we see all the different headers used. Then we only try to access the first or the index web page. Then why are there so many requests that have been sent to the server? For that, let's just press Ctrl U, or alternatively we can just right click and we can do view page source, and this will open up all the raw HTML code. Now this HTML code contains links or references to many other external URLs or other URLs which belong to Google. For example, there is a reference to the Google's logo. Now in order to get that Google's logo inside this web page, our browser has to make a request to the server again for the Google's logo. So anytime it encounters a reference in the HTML code for some other resource, it sends either a get or post request which is specified in the HTML file and includes that in the page. Now let us talk about HTTP headers. These headers appear in both the get and the post requests as well as in all the responses sent by the server. So what are headers? Headers are pieces of information or pieces which are used to send additional information to the server or the client. So these can be sent both to the server or the client, and their format is really simple. We have the name of the header followed by a semicolon and then its value. Now you might think that what role do these headers play? But these headers are really crucial in many things. They play a really important role in many things, including security, authentication, and many other things. We will take a look at two examples. First is the use of cookies, and the second is the use of virtual hosting. So let us now talk about cookies. But before understanding them, we need to understand one thing about HTTP, that it is a stateless protocol. There is no way of identifying if the two connections that we have received are from the same computer, and this was for a long time until cookies were introduced. So what are cookies? Cookies are like arbitrary pieces of data. These are stored by the web browser on our computer, that is, they are stored on the client as well as on the server. So what is the need for cookies? They are used to identify the particular browser or the user. So for example, let us suppose that we are using one of Google services. Let us take Gmail. So we are using Google Mail and we have logged in to the account using our email ID and password. Now if we have logged in once and we close the browser and we open it again and open Gmail, this time we are not prompted for the username and the password. We are simply logged in back. So this is the magic of cookies. So when the first time we log in, we are sent a cookie back from the server of Google, which is in the form of a header saying set dash cookie colon token equal to value, and that value is some arbitrary data, and this is stored on our computer. The next time we visit the website of Gmail, we send this cookie along with our request. So we have a special header in our request stating cookie token is equal to and that random value, and then the server looks at that value and identifies that this value was sent to this server and then correspondingly logs us into the account. So this is the use of headers in cookies. Another important functionality related to the use of headers is virtual hosting, which is also known as vHosting. It is a method of hosting multiple domain names on the same server. For example, let us suppose that we have two domains, metasploit.com and vulnerable.org, and these both are hosted on the machine with IP address 10.0.2.6. Now, to visit any of these websites, what we do is using DNS, we convert this name into its IP address, which is 10.0.2.6. We connect to this machine at port 80 and we send a get/request. Now, how does that server know whether we want to visit metasploit.com or vulnerable.org? And this is where the host header comes in. When we send the request, we also send which website we want to visit in the host header. For example, if I am visiting metasploit.com, my browser will automatically send a host header in the request, which with its value metasploit.com. Similarly, if I am visiting vulnerable.org, my browser will automatically have a host header in its request, which with its value vulnerable.org. Then the server will look at the value of this host header and then determine which web pages does it want to send to us. Now let us come to the problems with HTTP. Its biggest problem is that it is an unencrypted protocol, that is, it communicates in plain text. Now if you remember, in the last video we captured HTTP data using Wireshark and we were able to clearly view and understand all the communication going on between the client and server. Now suppose if the client was communicating about something sensitive or it contains sensitive information. For example, if the client visited a banking website and they are communicating in plain text, and then we would be able to leak credit card numbers, debit card numbers, etc., which is really dangerous. So its mitigations involve mainly two things. First is HTTPS and then second is HSTS. So what is HTTPS? HTTPS is Hypertext Transfer Protocol Secure, which is an extension of HTTP. It is the secure and encrypted version of HTTP. So it means that this does not communicate in plain text, and even if we capture the communication between the client and the server, we will not be able to make any sense out of it because it will be completely encrypted. This is used widely throughout the internet because of its security purpose, and its default port is 443. So HTTP's default port is 80 and the default port for HTTPS is 443. Now we are not going to discuss about why and how does HTTPS encrypt this, because that is largely based on mathematics and is out of scope of this video. So HTTPS is a lot secure than HTTP. Now there is a special feature in Firefox called HTTPS only mode, which will make sure that Firefox defaults back to HTTPS, and if the website does not support HTTPS, then it will prompt us whether we want to continue to that website using HTTP. And this feature is for now only available in Firefox. So we can enable that by clicking on this menu button, going to options, and then we have privacy and security, and below this we have an HTTPS only mode over here. So we have HTTPS only mode enabled. Now if I try to visit a website using only HTTP, then it will give me a warning saying that this website is only using HTTP and not HTTPS, and this is insecure. Do you want to continue? And this is a nice feature which should be enabled in every browser by default. The last thing which we have is HSTS. It stands for HTTP Strict Transport Security, and it protects against some different types of attacks called man-in-the-middle and protocol downgrade attacks. So suppose that we have already visited a website once using HTTPS. then that website will send us a header. So header is used again, called strict transport security header, and this will tell our browser that in the future if it tries to connect to that website, it should always use HTTPS, and if it is not able to use HTTPS due to some reason, then it should refuse to connect and it should not even try to connect to that server. And this is the use of HSTS. So if we are trying to connect to a banking website or some other website where we have to enter some sensitive information, and someone has launched an attack against us, and we are not able to use HTTPS and we are only able to use HTTP, and we have at least visited that website once in the past, and that website is using the strict transport security header, then our browser will refuse to connect and it will only connect to that website over HTTPS, and this is a really good security feature. Thank you for watching this video. I hope you got to learn something new today after watching this. Please like this video, share, subscribe and comment. Thank you.